Professor Bollhaus is going to start.
Vielen Dank. Grüß Gott. Guten Abend. That's it for German. So I'm very grateful that you invited me here, and I look forward to a nice discussion. Because as you can see from my title, I don't quite agree with everything that evolutionary psychology claims, and I will try to explain why I don't agree with that. And I want to specifically talk about two issues tonight, two what I would call misinterpretations of the theory of evolution, but others might not agree with me, and indeed they don't. Two of them, one is what I would call a medieval view of evolution. So evolution is not only about humans, but also about other animals, of course. In fact, that's a very important part of it. And I will talk about that in the first half of my talk. And the other issue, the problem that I want to discuss with you, is that of confounding evolution and mechanism, which I think is quite a prominent issue now. Well, of course, if we talk about evolution, we have to talk about the great man himself, Charles Darwin. And it's always good to start with him. And in The Descent of Man, of course, a pivotal book for the whole field, he says a lot of interesting things, but one of them is that, and I quote, "There is a much wider interval in mental power, or we could say cognitive capacities, cognitive abilities, between one of the lowest fishes," but he could just as well have said birds, I think, "and one of the higher apes than between an ape and man." So, in evolutionary terms, he's making quite a bold statement here, the genius Darwin, that there is a much bigger gap between an ape and a bird or a fish than between an ape and man. So there is a sort of continuum, but obviously some animals are more similar to us than others. And if you look at the evolutionary tree, this is a very simple version of it, catering for all kinds of ideas. Then intuitively that makes a lot of sense. If you look at this evolutionary tree, then you can see that the last common ancestor of modern man and the modern chimpanzee was walking on the earth about 5 to 6 million years ago, give or take a few. Whereas the last common ancestor of modern birds and modern man was probably crawling around considerably longer ago, namely about 300 million years ago. So in evolutionary terms, the sort of cognitive distance between us and birds is about 600 million years, because it goes both ways, a different development in the course of time. So intuitively you would think, well, if there is something in the animal kingdom, cognitively speaking, that resembles what we think and what we do, then you have to look at apes because they're so closely related to us, and not at birds. So it makes sense what Darwin said. But I think there are also problems involved in this kind of reasoning, and one of them is that there is indeed some kind of scala naturae in the animal kingdom. There's some kind of scaling going on, that some animals are more like us than others, and some are not like us at all. And of course the idea of a scala naturae is from the Middle Ages, where there was a kind of scaling in nature or in creation. We're talking about the Middle Ages here, where on the top of the scale were the angels. There was no mention of God, that was beyond everything. The angels were on top, and then of course followed by man, and then probably the apes and the higher mammals, as Darwin would say, and then at the bottom of the pyramid were the sponges and the worms and things like that. And that idea, of course, in a different form, is still quite prevalent, I think, in the thinking of a lot of people. I won't mention names now, but the idea that obviously some animals are much closer to us on this scale, psychologically speaking, cognitively speaking, and they would resemble us in the way they think. And that is the question whether that's really true, actually, and I think not. This is just one example. I'll mention briefly a few examples. This is a monkey, a capuchin monkey, and he has to solve some kind of fairly simple task, you would think. So there's a tube here, a perspex tube, you can see through it, and there's a rod here that you can push into the tube in order to get food. And of course, as you can see, if he pushes from this side, then the food will end up in the trap and he can't get at the food. If he would push from the other side, then the food would pop out and he would be able to eat it, which apparently he likes to do. So you would think it's very simple, but they have great problems solving this task. So they make lots of mistakes. About half the time they get it wrong. They seem to perform at random. These are monkeys. Apes are slightly better, but they're still pretty bad at this task. Now if you look at a different version of this task, obviously slightly adapted for a different kind of species, birds namely. These are crows, New Caledonian crows, are studied by Alex Taylor and colleagues in New Zealand. And now I hope that this, yes. So, of course, they don't have arms to push things with, but they have bills to pull things with. So they take a stick and they pull this out of this tube. And there's also a trap here, so if they would pull it the other way, then they would fall in the trap. They couldn't get at it. And they're very good at this. They're actually quite good at it, almost from the word go. This is another version of it, a slightly more complex version. A different kind of crow, a different individual. He gets a little stick. With the little stick, he can prise this big stick out of the cage, and only with the long stick he can get at the food. In this case, so he has to use one tool to get another tool, and use that tool to do whatever he needs to do with that tool. So what the authors call meta-tool use, and the title of their paper in Current Biology is also Spontaneous Meta-tool Use in New Caledonian Crows. So they do it correctly, almost from the word go, and again, monkeys and apes are pretty hopeless at this. They just can't seem to be able to solve this problem properly. So very surprisingly then, if you think in terms of an evolutionary scale, scala naturae, that the animals that are close to us in that scale, they seem to be pretty poor at this sort of cognitively complex task, perhaps. Now, this is the sound of a chaffinch, which is also prominent in this country, and the idea of a chaffinch, just like other songbirds, is that they learn those beautiful songs from a tutor. So they're not born with these songs in their head, but they have to learn them from a tutor. And these are sonograms, so the frequency of the song over time. And as you've heard, we work on birdsong, so this is a particularly interesting topic for us. But the interesting thing is that they learn from their father in most cases, in most species. So this is a son of that father, this is son of that father. You can already see by looking at the frequencies over time that they are very similar. And they're not inherited genetically or anything like that. They have to learn them from their father. And they can be quite complex songs and even quite complex repertoires of songs. And the interesting thing is that this auditory vocal learning that they're very good at, and of course humans are also very good at that. So human infants start to speak, first of all, by copying their parents or other adult individuals. And they're very good at that. So young infants can learn 10 new words per day, for instance, at some stage in development, from about 2 years old. They're very good at that. We are very good at auditory vocal imitation. Songbirds are extremely good at that. Certain marine mammals, like dolphins and whales and seals, are very good at that as well. But again, if you look at our closest relatives, apes or monkeys, they don't do that kind of thing. Maybe they don't need to do that kind of thing. They never evolved that kind of ability because they didn't need it, maybe. Who knows? But they simply don't do it. So again, in this fairly complex kind of behavior that you can copy complex vocalizations, we do it in a certain way, songbirds do it in a very similar way, but our closest relatives don't do it at all. Very surprising if you think in scala naturae terms. Sorry. And if you look at birdsong in slightly more detail, as we do every day, then there are lots of interesting phenomena there. One of them is that the song develops very slowly in these songbirds. So this is young chaffinch male, and they start off with a fairly simple kind of song. You can't even call it a song really. It's a sort of squeaking sounds that they make. And then in the course of time, with lots of practice, they get better and better at it. And they have a late sub-song, they have a plastic song that can still change. And finally they end up with what's called crystallized song, which is the song that they have to do with for the rest of their lives. So there are phases in the development of song, and some people have noticed, and it is actually rather an interesting parallel, that very similar things happen in human infants when they start to speak. Of course, they don't speak proper sentences to begin with, but they make funny squeaking sounds as well, and then very slowly they form what sounds a little bit like words, and very slowly they come up with real words and sentences. So they start to babble beforehand, before they start to speak properly. Very similar to what these songbirds do. And again, there's nothing like that at all in apes or monkeys. They don't have that kind of thing. They don't learn their vocalizations. Of course, they do vocalize. They don't have to learn them. So they don't have this phase as well. Well, there are more similarities, so we've already talked about this babbling phase in both species, surprisingly, and not in apes and monkeys. Also a sensitive period. It's very shown in lots of species of songbirds that there is a sensitive period that early in life they learn much better than later in life. And also, if you look at human infants, they are very good at learning all kinds of languages, even several languages at the same time, like this girl here. I know her rather well because it's my daughter. She learned 2.5 languages at the same time, whereas I would be hopeless at learning the languages that she can speak perfectly now. So the older we get, the more difficult it becomes for us to learn new sounds that we're not familiar with. And it's very few people that can actually speak a second language without any accent whatsoever. So there's apparently it's a sensitive period in our case as well. So there are lots of interesting parallels behaviorally. And a few years ago, with some colleagues, including Constance Scharf at the Free University in Berlin, we sort of reviewed all those parallels between birdsong learning and human speech and language acquisition. So there are behavioral parallels, there are also neural parallels. I don't have time to talk about them, but you can read all about it in that paper. There are also genetic parallels, similar genes, almost identical genes are involved in both cases, underlying the vocal behavior. There's a lot of debate these days, but there are also linguistic parallels, because songbirds have these complex vocalizations. They learn in a very similar way to the way we learn speech. Might it not be the case that they also have language, like a grammar that we have? A lot of debate about that. We have concluded that they probably don't, but we can come back to that later. So the question arising in all these examples, I think, is that whether we are dealing with common descent, so the fact that these guys are much more closely related than these guys in evolutionary terms, does that say anything about what you can expect from their cognition or their behavior? And of course, in a lot of cases, it would say a lot about it. So, for instance, just a trivial example, birds fly and we don't, and apes don't either. So we are much more similar to apes, or apes to us, in that sense. But in the examples I gave to you, so these complex cognitive tasks and this auditory vocal learning, the songbirds seem to be much more similar to us than these apes. They don't do that kind of thing. So another factor, evolutionary convergence, that not closely related taxa, in this case, come up with similar solutions to similar problems. In this case, the problem would, for instance, be auditory vocal imitation learning in the course of evolution and independently. And apparently that's also a factor, and I will come back to that later. And it's very difficult to predict beforehand, are we dealing here with convergence, or are we dealing here with common descent? So it's very difficult to predict from evolutionary principles what you can expect if you look at the mechanisms. And I can give lots of examples of that. Well, some years ago we wrote an essay in a popular journal where someone made a very nice cartoon, I think. So this is monkey or ape and doesn't have a clue what to do here. Whereas the parrot in this case could not only say apple if he wanted to, but he can even say golden delicious. Although he actually gets it wrong because it's not a golden delicious but a Granny Smith. But nevertheless, he or she is very, very good at it. So, yeah, joking aside, so I would say common descent and convergence are important. So we've seen examples of these complex tasks, of this auditory vocal learning, where convergence apparently seems to play a big role. And of course, it's not really a mechanism or a process; it's just a random thing. But it seems to happen in different taxa that are not closely related. But also, common descent also plays a role. So, and I will try to explain that in a moment. Because there's a third factor involved, I think. I already mentioned this current debates that are going on, whether songbirds with their complex vocalizations have a kind of grammar in these vocalizations, whether you can speak of a simple kind of language, or language of birds. And a few years ago, I and some colleagues of mine reviewed all the evidence that was there at the time, and we concluded that, well, they are very complex, these vocalizations. For instance, Bengalese finches have very complex orders of elements in their songs, with certain rules to it, kind of phonological syntax it's called. But this syntax is nothing like even the simplest human language. Doesn't have that kind of simple syntax. So the syntactic structure of human language is infinitely more complex than the most complex birdsong. would be. It's a hierarchical structure with complex interactions between the different elements, which songbirds simply don't seem to have, as far as we can see. Okay, so come back to this idea of common descent and convergence. As I said before, both are important. So on the one hand, common descent does play a role. Apparently, homology is important. I couldn't discuss the neural mechanisms of, for instance, birdsong learning and speech and language. But basically, you can say that the neural mechanisms are there for all the species involved. So they are there in humans, they're there in apes, they're there in mice, and in zebra finches and all kinds of other animals. The machinery is already there. They have neural structures involved in vocalizations, they have neural structures involved in auditory perception, in auditory memory. It's all there. They also have FOXP2 genes, for instance, which are important in vocalizations. Monkeys have them, mice have them, humans have them, obviously, and zebra finches have them as well. So the machinery is all there. It's just that different species or different taxa use this machinery in different ways. We use this machinery to have auditory vocal learning, and songbirds have a very similar form of auditory vocal learning with a similar kind of machinery that they use for it. Similar genes are involved, similar brain structures, possibly even homologous brain structures. And apes and monkeys simply don't do that kind of thing. They for whatever reason, they don't do it. But there's also a third factor which I just discussed, namely that it seems to be the case, as far as we can see now. Of course, the new evidence might pop up that will change our minds, but we haven't seen it yet. That which I call specialization here, where the idea of a language with a complex syntax, with complex rules, or actually quite simple rules, but nevertheless it leads to a very complex language, is only present in humans as far as we can see. So no other species seems to have that kind of complexity in which we call language. So there are three factors involved, in fact, I think. So that was the first question the first problem I wanted to discuss. So it's very, very difficult, if not impossible, to make any kind of prediction from evolutionary principles about what kind of mechanisms we might expect to find, both neural mechanisms, behavioral mechanisms, cognitive mechanisms, in different species of animals. The other problem is that, which is very prevalent not only in animals but particularly also in humans, and of course we concentrated on that this evening, is that what I would call confounding of evolution and mechanism. And what do I mean by that? Well, we have to go back to my compatriot, although in fact at some stage, when he won the Nobel Prize, he was actually British, but we like to forget about that, where I come from. And he went to Oxford as well, so yeah, he was Dutch, he was born Dutch, but became British, unfortunately. Anyway, so he, in a famous paper in 1863, on the occasion of Konrad Lorenz's 60th birthday, I believe, he wrote a very interesting paper where he sort of discussed what are the main principles, what are the main problems in our field of ethology, as it was called in those days, or animal behavior, as we call it now. And he identified four big problems that people should be addressing. One is the problem of evolution. Well, we are all discussing that this evening, so that's obviously, we would agree with that. The other is the problem of function, or what he calls survival value. So what is a particular behavior for? What are the consequences of that behavior? The other one is development, or what he called ontogeny. So how does the behavior develop in the course of the life of an individual? And the last problem is what he called causation, what causes this behavior. I think nowadays we would call it mechanism. What is the machinery underlying that behavior? So these are four important questions, and I think we would all agree with that these are the questions you can ask. Some people would like to ask all of them, and some people have tried to mix them up. And I think problems can arise when you do mix them up in a certain kind of way. And I would like to briefly discuss the problem in the case of evolutionary psychology. Because I think one of the problems there, but not everyone agrees with me again, is that different questions in different domains are being mixed up in evolution. Well, what is evolutionary psychology? What is EP, as it's often called? Evolutionary considerations, I think, are being used as explanations for human cognition. So why do we think the way we think, we modern humans, has something to do with our evolutionary history. That's the idea, I think. And basically then the mind stroke brain has evolved as a result of selection pressures in the Stone Age, according to some evolution psychologists. Others might disagree with that, but that's a prevalent theory still, I think. Anyway, somewhere in the past. And yeah, that it's taken off really well. It's a very popular field. And evolutionary psychologists tend to write nice popular books about it, and they tend to write well. Often it's couples that are writing, apparently, and so this is one of those books, Madame Bovary's Ovaries, and as I've said before, I think the nicest thing about this book is its title. It's a very nice title, but the rest is just, yeah, weird. It's about, you know, the sort of evolutionary psychoanalysis of fictionary characters. So these people don't even exist, but you know, Madame Bovary was an adulteress because in the Stone Age something happened that made her behave like that. Other people have become more serious and try to develop EP as a serious science. That, you know, this is really something, and some people have even said that, like Tubi and Cosmides, that you can only understand the workings of the modern human mind if you consider evolutionary history. Otherwise, you would never be able to understand it. That's going quite far. So this is, you know, more serious science, always on big topics like jealousy, love, and sex. And if you consider yourself to be a serious scientist, you can expect serious discussions. And this is one example, a very fine book by David Buller, where he criticizes in great detail, it's quite rather a thick book, in great detail, various positions taken by evolutionary psychology, and yeah, doesn't leave much standing. One example is, yes?
Could you please repeat the name of the second author?
This one, David Buller.
B-U-L-L-E-R.
B-U-L-L-E-R, yes. So David Buller, this is, I think, from a Scientific American paper. He reanalyzed some of the data from, I think, from some EP study. I don't know who the authors were exactly. But this is just one example of the kind of work that you can expect. And this is again about jealousy. So this is about students. I think mostly it's students involved as subjects. And the students are asked all kinds of questions in a questionnaire. And one of the questions is, what would you find worse? What is more upsetting to you? If your partner has an emotional relationship with someone else, for instance, is in love with someone else, or if your partner is having enough with someone else, has a purely sexual relationship with someone else, what is worse for you? And for instance, here is the outcome of the percentage of choosing sexual infidelity as the more upsetting. And it turns out that males, these are several studies done in the US, male students find sexual infidelity much more upsetting if their girlfriend or partner is having enough with someone else, much more upsetting than if their girlfriend would fall in love with someone else. That's not so bad. And in females, it seems to be the other way around. That if their partner has an emotional relationship, that's far more upsetting than a sexual relationship. So, and the idea behind it is that the males are promiscuous, and males trying to fertilize as many females as possible in biology, and whereas females trying to bond with the males and keep them with them to jointly take care of the offspring. That's a sort of vague evolutionary idea behind it. More about that in a moment. But if you look at the data, as Buller has done, then if we go on, then you can see if you move more towards the east, towards where I'm from, in the Netherlands, for the Dutch males, it's about 50-50. So some find the sexual infidelity more upsetting, but others not. And if you go even more east to where we are now, in Germany, the German students are even quite different yet again. So the German males are very much like the American females. So they are much more upset when their partner has an emotional relationship with someone else. And you can go on to Japan, etc. But the point that Buller is trying to make, and I think it's an interesting point. I mean, I don't know what the outcome of it will be, but I'm not in this field. But the point he's making here, that look at the differences between different countries even. So Japan and the US and Holland and Germany, they're completely different. So the differences are so big, they are bigger than differences between males and females. So might it not be the case that certain stereotypes that are prevalent in a particular society about the roles that males and females have to play in life might influence the way people think about it. So if people think about it that males can be promiscuous, then maybe they have a different attitude than when they don't think that. And so his conclusion is that one should not ignore cultural factors, and perhaps even cultural factors are much more important. Well, another example that I just dug up from I often read the BBC website, it's very interesting, they have lots of interesting news on it. And so this was one some time ago, beginning of this year, I think, February, where the idea was that some people did a study on speed dating, and so maybe I don't know whether you know what that is, but so people choose they go to some hotel or something, and then females are seated at tables, and then the males can walk around and have a little discussion with the female for 5 minutes, and then some bell rings or something, and then they have to move to another table. And so the males move around from table to table, and they have short discussions with various females, and then afterwards they can say that, well, I'd like to see that one again. And females can say the same thing, well, I don't want to see him again, but I'd like to see him. And the idea was that males had much more, I'd like to see her and her and her, whereas the females were much more choosy, that they said, well, I don't want to see him, but I might want to see him, but I'm not sure yet. So females are supposed to be more choosy, and again, that seems to resonate with the sort of vague evolutionary idea that males are promiscuous, and females want to bond with one particular male and keep him with her to take care of the offspring. So it makes a lot of functional and evolutionary sense, you would say, but then some study, also done in America, showed that it is actually rather different if you make a small change in this setup. And this is all published work, so in psychological journals. Namely, if you put the men at the tables and let the females walk around and start the discussion, so every 5 minutes the females have to move around, then it's quite a different picture. So this is the traditional setup that people have used, and then it looks like so the yes responses, so the men want to date with many more subsequently than the women do. But if you make the setup slightly different, then it's this sort of 50-50. In fact, the females are slightly higher than the males here. So this so-called choosiness, it seems to sort of disappear when, with a slight change in the setup, that the males have to sit down and the females walk around. And there's all kinds of aspects there that is discussed in the paper, that maybe if you can walk around and start up conversations with different women, that makes you feel more powerful or something, or more secure, things like that. And also they ask the people who organize these things that why do the females always sit down? And so, well, the females, they often have handbags with them, so it's a bit awkward if they have to walk around. And also it's more chivalrous for men to do the walking, and you shouldn't ask the women to do it. So already this is some kind of sex roles are being put into it. That, females don't do that, or males do it. So again, I think there is a lot of indication here that maybe cultural conventions are much more important than evolutionary principles. And in fact, if you look at what's called Bateman's principle, so promiscuous males and non-promiscuous females, which Julian Brown and colleagues have done some years ago in tree, they found that it doesn't really work that way all the time. So there are lots of animal species, but also human societies where it's actually the way around, that the females are all promiscuous and the men tend to much more take care of the children, for instance. So it's not a set principle, they argue. And I think that's an interesting point. Okay, well, why do I think that evolutionary psychology doesn't work? And again, a lot of people violently disagree with me, but others don't, luckily. Well, first of all, there are no cognitive fossils, so the brains don't fossilize, and thoughts don't fossilize either. They're not really, anyway. And so it's very difficult to reconstruct evolutionary history of mind and brain. You can make attempts to do it, but they often fail. So you often end up with just so stories. Well, it seems very likely to me that in the Pleistocene that the men were hunters and the females weren't, and so they must have behaved like this, and therefore we still do. And there are all kinds of other problems with that as well that we discuss in a paper that I haven't got time to go into. Also, as I already indicated in what Buller and others have said, that apart from biological evolution, so genetic evolution, there's also cultural evolution. And of course, you know, I would hope that we think quite differently from our medieval ancestors, and let alone the old Greeks or the Stone Age man. So there's been a huge cultural evolution, if you like. So we think completely differently from even a few generations ago, luckily. And obviously that plays a big role. And in fact, it might overrule any kind of remnant biological factors involved. But I think for me, the most important point here is that if you go back to the 4 questions of Tinbergen, that evolution is not about mechanisms. Evolution, the theory of evolution, is about history. It's a historical science, almost, if you like. The idea of evolutionary theory is to try and reconstruct how did this all come about in the course of history? What happened beforehand? How could this have evolved? Are we dealing with common descent? Are we dealing with convergence? Or is there some kind of other factor involved? That's what evolutionary theory is about. If you talk about mechanism, what's going on in the brain? What kind of brain mechanisms are involved? What kind of psychological or cognitive mechanisms are involved? Then you should do cognitive psychology or cognitive neuroscience, I think. But again, not everyone thinks like that. What can you do with evolutionary theory if you want to talk about mechanisms, if you really want to? You can try to look for clues. So it could be the case that, you know, if you can reconstruct the evolutionary history of a certain trait, like auditory vocal learning or whatever, or language, as some people have tried, but that's a very tricky one. You can try to come up with some kind of reconstruction. Well, it probably evolved like that, and then you can also get clues about, well, if the behavior evolved like that, it might also be the case that the brain evolved like thus and thus, and maybe there are certain parts of the brain that are involved in this and that. It might also be the case that the cognition evolved like that, that certain cognitive mechanisms evolved to accommodate this particular trait. It's all possible, but there are lots of examples that I haven't got time to go into that show that these clues are often misleading, in fact false. That, you know, the idea was that it works like this. Food storing birds with bigger hippocampi, for instance, is one popular hypothesis. Turns out it's not the case. It's just simply not the case. Okay, so you have to be very careful with it because they are clues. They are. You can generate hypotheses with it, but they are not explanations. They can be misleading. They are not explanations. They don't explain it. It might have worked that way, but often it turns out that it didn't work that way. So you can never use it as an explanation. Okay, to conclude then, well, I think it's completely obvious that brain and cognition have evolved. You know, once there wasn't language, and now there is language, just to give one example. So all these things have evolved, like everything in the living world has evolved. That's obvious. But the question, you know, has it evolved by way of common descent? That the relative evolutionary distance is an important factor, or not? That's a difficult question to answer beforehand, and you can only answer that by testing it. And we've seen lots of examples where common descent doesn't seem to play a role at all. So convergence often plays another role, and of course it can also be something completely different. That, you know, it's just some kind of random thing. For instance, in terms of language, that seems to be something that only appeared in humans. And I think the most important point that I want to make is that evolution is one of the 4 main questions, so together with development, function and mechanism, and it's about evolutionary questions are about evolution, about reconstructing the history of traits, and they're not about mechanisms, and they can't tell you very much about mechanisms apart from giving you some clues about it. So on that note, I'd like to thank you for your attention and just show you some of the people that I work with. Thank you very much.
I